Okay, so today's notes are on rational expressions, specifically simplifying, multiplying, and dividing them. So that's our objective in our language, our content objective, and our language objective is to use the correct terminology to explain and describe those processes. So let's first jump in with defining what a rational expression is. So a rational expression is the quotient. Quotient means dividing, if you've forgotten. So the quotient of two polynomials. So this is just another way of saying ratios or fractions, or just as the definition said, quotients. So it's when you have one thing over another, or one expression over another. And since one of our goals is going to be simplifying, let's continue to define what simplest form is. So simplest form is when the numerator and denominator of a rational expression have no common divisors. That just means you have sufficiently canceled out everything that occurs in both the numerator and denominator. So just some quick visual examples. These expressions are in simplest form. So I have x plus 1 over x minus 1. There's nothing that can be canceled there because these are whole binomials or expressions. I can't cancel parts of them when they're adding or subtracting. I can only cancel them when they're being multiplied. You could also have something like x squared plus 3x plus 2 over x plus 3, because even if I factored this expression, it'd be x plus 2 times x plus 1, and nothing can cancel out there. So this is also in simplest form. However, these are not in simplest form. I could have something like x over x squared. So there's at least one x that could be canceled there, so that would not be simplest form. Similarly, I could have 3 times x minus 3 over x minus 3. So since I could cancel that whole binomial, that would not be in simplest form as is. And then there's also x squared minus x minus 6 over x squared plus x minus 2. Because similarly, if I factored both the numerator and the denominator, I'd be able to cancel at least one of the factors. So let me show you what I mean with that. I'll take that last example. So our simplifying example, we have x squared minus x minus 6 over x squared plus x minus 2. So step 1 here, I'm going to have us factor the numerator and denominator. So this is why factoring never goes away. So I'm finding factors of -6 that add to -1. That's going to be -3 and +2. So I have x minus 3 times x plus 2 for my numerator. The denominator, I need to find factors of -2 that add to +1. So those are going to be -1 and +2. So x minus 1 times x plus 2. And at this point, you can see that there is a common factor here, x plus 2. So since x plus 2 is a factor in both the numerator and denominator, I can divide them out since everything else here is being multiplied. So these are all being multiplied, so I can cancel out, or these two expressions in the numerator and the denominator are being multiplied, so I can cancel out the common factors. So I cancel the common factors. I also want to note, so the other thing I want to note, or I want to write my simplified expression. So this is going to be x minus 3 over x minus 1. 4, and when I write 4 because we need to note the values of x that would make this undefined. So my last other step is note values of x that make the original expression undefined. So originally, x could not equal 1 because, or still here, x can't be 1 because if I plug in 1 for x, my denominator is going to be 0, which you're not allowed to do. That makes it undefined. And similarly, x can't be -2 because if I plugged in -2 here, then I'd get a 0 in my denominator, which also would make my expression undefined. So my answer would be x minus 3 over x minus 1 for when x does not equal 1 and x does not equal -2. So again, you're canceling out things, but you still have to account for those values as values of x that would make your expression or your expression undefined. So we're gonna do a quick check. I'm gonna flip the page for it. So our quick check here, number 1, it's gonna be the other two that were in the not simplified expression. So x over x squared, and the second one is going to be 3 times x minus 3 over x minus 3. So try those each on your own. I'm going to go over them now. So here, this would just become x over x times x. So I can cancel one of the x's from the numerator and the denominator, which leaves me with 1 over x. So my answer is 1 over x for when x does not equal 0, because again, if I plugged in 0 for x here, then I would end up dividing by 0. So that would be my solution for that expression. Here, similarly, I'm not even going to rewrite it because I can see x plus 3 can cancel in the numerator and denominator. Since these are being multiplied, I can cancel those expressions. So I end up with just 3 for when x does not equal 3. So I still have to account for that, but x can't be 3 because that would have made our original denominator 0. All right, so now let's get to multiplying. So I'm going to do our example for multiplying rational expressions. So here, we're starting with multiplying and dividing rational expressions because those are actually easier because we just multiply straight across. So here I'm going to ask us, what is the product of x squared plus x minus 6 over x minus 5 times x squared minus 25 over x squared plus 4x plus 3. And that's a question mark for the end of that sentence. So what is the product of that? Step 1, I'm going to make a quick note. You multiply rational expressions or fractions straight across. So multiplying, you multiply both the numerator and the denominator. That's different than adding. We'll get to that next lesson. But you multiply them straight across. So I can just write these all as one thing being multiplied. So I'm going to step 2, factor all polynomials. So now, because I want to cancel as many factors as I can, I need to start by factoring all of these terms. So again, I'm going to factor that. Factors of -6 that add to +1 are going to be +3 and -2. I recognize this as the difference of perfect squares, so it's x squared minus 25. So I know it's going to factor to the conjugates, x plus 5 times x minus 5. And that's all over. The x minus 5 can't be factored, but then I'm finding factors of 3 that add to 4. That's going to be +3 and +1. So that's my fully factored rational expression. So then I'm just going to start canceling things. So step 3, cancel common factors. So here I have x plus 3 and x plus 3 that cancel. And then I have an x minus 5 and x minus 5, so those cancel. So I'm left with x minus 2 times x plus 5 all over x plus 1. But I still need to note values of x that make the expression undefined. And then again, you have to go back to the original equation and see what values of x would make that original equation undefined. So this is our answer for when x does not equal 5, x does not equal -3, and x does not equal -1. So just all those values of x would make the original denominator 0, making the expression undefined. So those are my values of x that do not work for that expression. For the sake of time, I'm going to skip this quick check and we'll go over it together in class, but I'm going to flip the page and do one example of dividing rational expressions with you. So I'm going to flip the page of that so there's plenty of room. If you're listening, please send me a quick email and let me know that you are listening to the notes. So our example is dividing rational expressions. And my question is, what is the quotient of two minus x over x squared plus 2x plus 1 divided by x squared plus 3x minus 10 over x squared minus 1 in simplest form. So for this one, it's going to be a very similar process. The only thing that you have to do, the only added step for this that's different from multiplying is you have to flip the second expression. So you're going to flip the second expression, which is a simpler way of saying take the reciprocal, or a non-vocab way of saying take the reciprocal, and multiply straight across. So that's what I'm going to do first. I have 2 minus x over x squared plus 2x plus 1. And now it's going to be multiplied by x squared minus 1 over x squared plus 3x minus 10. So this is how you divide fractions anyways. You flip and multiply by the reciprocal. So it's the same thing as you would do with normal fractions. We're just now adding in variables. And now it's just the same process as multiplying. So step 2, you're going to factor all polynomials. So I have 2 minus x, which I'm going to do a little side note here. This is the same as negative x plus 2, which then becomes negative x minus 2. And I note that because you want to make all x values positive, just because it's going to make factoring easier. So again, just to show you what I did, I flipped the order. I did negative x plus 2 and factored it a negative so that the x in there was positive. And then I have x plus 1, x minus 1, because again, this is the difference of two perfect squares. So it factors to the conjugate. So x squared is a perfect square, 1 is a perfect square, factors this way every time. Then I'm looking at my denominators. I'm finding factors of 1 that add to 2. And that would be x plus 1 times x plus 1, or x plus 1 squared. I'm going to write it out as 2 factors though, so I can see all of them individually. Then I'm finding factors of negative 10 that add to 3, which would be positive 5 and negative 2. So again, factors of negative 10 that add to positive 3. Now I'm going to cancel my factors, or common factors. So here are my common factors. I have a plus 1 and a plus 1. I have a minus 2 and a minus 2. And that is all that I can cancel out. So then I have negative x minus 1, because the negative sign is still there, over x plus 1 times x plus 5 for, so again, note values of x that make the original expression undefined. So when I do that, x cannot equal -1, x cannot equal -5, and x cannot equal 2. So that is my final answer there. X can't equal -1, -5, or 2, and that is my fully simplified expression. For the sake of time, that will be all. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.